Hello and welcome to this Bioprocess International Ask the Expert webcast. I'm your host, Leah Rosen, the online editor for Bioprocess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We have muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we will begin the question and answer portion because this is, after all, Ask the Expert. And I will ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. So with that, I'd like to thank you for joining us today. It is now my pleasure to introduce our speaker, Serena Fries Smith from Thermo Fisher.
Thank you. Hello. Today I'll be talking about advancements in feed solutions and how we at Thermo Fisher Scientific are taking medium and feed development beyond maximizing protein titers to optimizing glycan distribution and simplifying process scale-up. I will start by discussing some industry trends and then about how leveraging feed design and feeding strategies can optimize glycosylation, simplify scale-up of the fed batch process, and also give your titers a boost. Finally, I will discuss how these advancements can be modified to meet the needs of your specific product and process. It is not surprising that industry trends have shown an increase in titer over the last 30 years. Just will take a minute to see how far we've come. In 1994, the average industry titer was 0.5 gram per liter. And there was a lot of pressure to increase this in order to make a more economical product. In part, due to improvements in medium and feeds, titers increased to 1.3 grams per liter in 2004, and in 2014 reached 2.5 grams per liter. That's a 5-fold increase in the last 20 years. And what's more exciting is that some processes are reporting up to 7 grams per liter. So where do we go from here? Do we continue to focus on maximizing titer, or do we begin to focus on some other industry challenges? At Thermo Fisher, we've started to tackle some other industry challenges. We have developed breakthrough feed formulations that can modulate glycosylation, and through our advanced granulation technology, or AGP, we have been able to simplify the process of dealing with dry format media and improve the nutrient delivery to the cells to aid in process scale-up. First, to discuss glycosylation. We're all aware of the importance of measuring and characterizing glycosylation of antibodies. But why would we be interested in tweaking this quality attribute and targeting a specific glycan distribution? Well, this becomes critically important if you need to match a reported glycan distribution for an existing product. Two examples of this are when transitioning to a new clone used in an existing process, or when you are creating a biosimilar and you need to match the innovator's profile. Another application is when you want to target a specific glycan pattern to optimize the efficacy of a molecule. Because of the applications discussed on the previous slide, not one glycan pattern is better than another for all products. What we have shown in this slide is that you can take a clone that is producing an antibody with the glycan profile shown in number 1 at 90% G0F, and just by adjusting some critical components in the feed, fit that pattern to what is shown in number 12. With only 35% G0F. And by changing the concentrations of these components and the time they are introduced to the culture, you're able to target any of these patterns between the two. And you can target any of these patterns to meet the needs for your specific product. Now I'm going to shift gears from the feed formulation to the feed format and discuss how feed formats can help simplify processing. As mentioned, the advanced granulation technology, or AGP, will simplify working with dry formats and reduce the risk of formulation errors. Additionally, through innovations in feed manufacturing, we have developed solutions that can help that can be super concentrated, allowing for more efficient use of bioreactors. This slide depicts how the super concentrated feeds can make better use of the available working volume of your bioreactor. In a traditional fed batch process, you may add 30% or more of a nutrient feed. By using a feed that can be concentrated 3x, the feeding volume decreases to less than 10% and still allows you to deliver the same amount of nutrients to your cells. By reducing the amount of volume that is added through feeding, the initial working volume can be increased. That's what's shown in this last column here. Additionally, this will minimize the volume change in the bioreactor, resulting in less dilution of the product and more efficient control of the bioreactor. The schematic here highlights how using an AGP format can reduce errors through simplification. In a typical 2-part feed, you may have up to 16 process steps, which include multiple pH and osmo adjustments. In a dry powder 1-part feed, you may still have up to 10 process steps, also including pH and potentially osmo adjustments. With an AGP format, there are only 6 steps. And there is no need for pH or osmolality adjustments. Not only does this reduce the opportunity for error, it reduces the need to manage additional raw materials for those adjustments. And to make it even more enticing, the GIBCO Efficient Feed Plus products are stable at room temperature for 30 days after reconstitution. This reduces the amount of time the material needs to be transported from cold rooms into production areas and reduces the frequency of feed preparation. Now, I've talked a lot about how this technology will simplify your process, but at the end of the day, we still care about performance and Titer. Here I am showing 2 applications of the Super Concentrated Efficient Feed Plus product. On the left, we are comparing the standard feed added at 13.3% volume to the 3X Efficient Feed Plus product, also fed at 13.3%. Increasing the nutrients without adding any additional volume resulted in over a 2-fold increase in Titer. On the right is the comparison of the Efficient Feed A Plus products, fed at 1X, 2X, and 3X. In this example, we fed less at the higher concentrations, essentially feeding the same amount of nutrients without increasing the volume. In this example, we saw roughly a 35% increase in Titer, due largely to minimizing the dilution effect. To wrap things up, I want to go back and remind you that the advances that Thermo Fisher has made in medium and feed technology are not only available as catalog products. These same technological advancements can be applied to custom solutions to meet the specific business and technical needs of our customers. And some of those examples are shown on this slide. To learn more about what I discussed today or about developing custom solutions for your process, please reach out to me at serena.smith@thermofisher.com. Additionally, my colleagues and I will be at BPI in Boston later this month, and we'll be sharing additional information on the Glycan feed. So that was a lot of information in a short amount of time, and now I'll take any questions you might have.
Thank you, Serena. So the first question is, how much development time would be needed to get a targeted glycan profile from an existing process?
To answer that question, I'm going to go back to the previous slide. So in order to tweak your glycan profile to meet meet your targeted glycan distribution, you can do this in as quickly as it takes you to run a fed batch process. If you design the fed batch process in such a way that you are evaluating multiple conditions to really see the full range of how the products will work within your cell line and work to adjust glycosylation. So typically, I would recommend like one project to do, or one experiment to do a screening to hone in on the glycosylation that you're looking for, and then a second experiment to really optimize and finalize that process. So assuming you have cells available, you can do this within a month.
Okay, and referring to the slides, are these fed batch or perfusion applications in the examples?
So the feeds that we've developed, the efficient feed plus products were developed primarily for fed batch applications. We know there are some customers that are using this for perfusion. A lot of our catalog media products are also used for perfusion.
On slide 10, the data showed for titer increase upon concentration of the feeds. Are these based on customer data? And if yes, is it one customer or multiple customers?
Right, thank you for that question. This is actually in-house data that we've put together here. I'm not showing any customer data in this presentation.
Do you have concentrated efficient feed in liquid format for sale? Is that available?
So currently the efficient feed plus products are available only as AGP, and what this does is it allows you to concentrate the product as you need it. So if you need it at a 1x concentration or a 3x concentration, you can only adjust that if you get it as an AGP, and then you can do that in-house. If you're only able to work with liquid products, we can look at preparing that for you as a custom product. So reach out to me offline and I can help you get that information.
And will the Glycan modulation work with other cell lines such as NSO?
The products have been developed primarily for CHO. The same technology can likely be used for NS0 projects as well, but that could be more of a custom project where we can partner with you to help identify the right solution to meet your needs for that.
Okay. And when you use concentrated feeds, how much of an increase in osmo do you see?
Obviously, as the products are increased, the osmolality is increased as well. So you would have to, there would be an adjustment there. Unfortunately, I don't recall the specific osmolality at 3x of efficient feed A plus off the top of my head. That's something that I can get back to you with offline.
Okay. And on slide 10, which we're looking at, for the experiment on the right, the volume reduction increased titer concentration. Was the total mass yield also increased?
The total mass yield of the protein or of the feed that was added. So if you're the total mass of the feed would increase as you're increasing the.
They're talking about the protein. Yeah, the protein.
To be honest, I'd have to go back and look at that and do the calculation again.
Okay.
I don't
You'll
have
get
that information off the top of my head.
We'll give you the questions at the end, so you can follow up.
Okay, great.
That. So, looks like we're going to get one more question. So, is the 3 times the highest concentration feed you've looked at, and are special mixing equipment needed to make these higher concentration solutions?
Okay, so at the 3x concentration, you do not need special mixing equipment. It'll go into solution very quickly, easily with the AGP format. And this is the highest concentration where we've done the room temperature stability analysis of. So potentially might be able to push it a little bit higher, but 3x would be our current maximum recommendation.
Okay, well, thank you very much, Serena, and thank you all for joining us today. As I said, we'll be passing on your questions, so if we didn't get to your question, Serena will get that after the presentation and can follow up directly. And if you have any other follow-up questions, her email address is listed here, and we'll be sending you an email with the webcast on demand so you can follow up or share it with your colleagues and refer to it. So thank you again for joining us for this Bioprocess International Ask the Expert. Have a lovely first day of October.